All right, let's take a look at half-life problem number 1. Now, this says that iodine 131 is used to destroy thyroid tissue when treating an overactive thyroid. And then it says a hospital's 240-gram supply of iodine 131 is now down to 30 grams, only 24 days after it was received. So they got in a shipment of iodine 131. It has been decaying. A portion of it is no longer iodine 131. So the amount that they started is not what they currently have. They started with 240 grams, and now they're down to 30 grams 24 days later. And that's because it was undergoing decay. So what we're going to try to do is answer these questions here. And what you need to do, since the only information given to you in the problem is really how much you have at the beginning of this time period, is look at a graph, because you don't know what the half-life is for this. You could theoretically Google it, but you have a graph here that's given to you. And if you notice on the graph, at time 0, there's 240 grams of that iodine 131 present. So you are going to imagine this 0 at the beginning of the x-axis always as the beginning of the decay process. Pretend it's like a stopwatch. Somebody has just hit the go button or the start button on the stopwatch. Now time starts passing. 2 days in, 4 days in, 6 days, 8 days, and so forth. What we want to do is answer these questions based on the graph and using this little chart here. And this is going to help kind of keep things organized for you. So, what's the half-life of iodine 131? I don't know at this point, but I'm going to start off with the mass of iodine at time 0 is 240 grams. I know that my mass is going to go down, down, down. So it's going to go down by half. Every half-life that passes, whatever that time period is. Maybe it's 8 seconds, maybe it's 24 days, maybe it's 2,000 years. I don't know yet. I'll find out in a minute. But I do know that the mass that I start with is going to go down, which is what your graph shows. Now, when we fill out this chart, there's a couple things I want to point out. The first is elapsed time. 0, no time has gone by. It's 0 always in the beginning, which we saw in our graph. And if you looked at the graph, you knew that at time 0, there's 240 grams present. Remember, always at time 0, look at where that curve hits the graph, and that's how much you've got at time 0, before anything has decayed. So fill in 240 grams. Now, we know this amount is going to go down, down, down. But what you have to remember about half-life is that it always gets cut in half. So if you start with 40, after the first half-life, see where it says after first half-life over here. After the first half-life, whatever time period that is, it's going to now be cut in half. 120 grams are present. So let's use our graph and let's find out how long it took to get to 120 grams. So go on your graph, find the 120 gram mark, go over till you hit the curve, make a little dot, and then look down. And if you do that, you realize, oh, it took 8 days. Well, that's the half-life. That is how long it took for the sample to get cut in half. So we now can answer the first question. What's the half-life of iodine 131? 8 days. Sometimes the problem is really nice because it gives you the half-life. Sometimes you have a graph and you've got to figure it out. But now we know the half-life is 8 days. So fill that in over here. Half-life is 8 days. And I don't have a lot of room to write anymore, so I'm just going to put 8 instead of writing 8 days every time. But this top row is always going to be the same. You should be thinking, for this particular isotope, it's always 8-day segments or 8-day periods. The first half-life means 8 days have to pass. Then another 8-day period for the second half-life. And then another 8-day period. And another 8 days and another 8 days. So we're thinking in groups of 8 days. But that's not really practical. What we want to think about is how much overall time has gone by. Once we hit start on the stopwatch, time goes by and the elapsed time value should go up. So you could think of it as a little easy math problem. 0 plus 8 tells us that we are on the 8th day. Then another half-life goes by, which means another 8-day period. So 8 plus 8 puts us on the 16th day. So on the 16th day, we could use our graph and find out where we are. Oops, let me erase that. On the 16th day, we could figure out where we are, or we could use some logic and the definition of half-life and say, well, if I had 120 days and another half-life went by, now I only have 60 days, or 60 grams rather. So if we check our little graph here, sure enough, we go over 60 on the 16th day. That's how much we have left. And then another 8 days, that puts us on day 24. And what's that? Well, it's about 30 there. It's half of 60. So this graph should correspond to the information that you're filling out in this table. So we start off at day 0. We haven't started the clock yet. We got all of our sample, 240 grams, arrives at the hospital. 8 days goes by, first half-life. Now we're down to 120. Another 8-day period goes by. Now we're on the 16th day overall. We now have 60 grams left of our sample. The rest has decayed. Now another 8 days goes by. 16 plus 8 is 24. We're on the 24th day, and 60 gets cut in half. We're down to 30. Another 8 days goes by. Now we're on the 32nd day. 30 gets cut in half. We're down to 15. And finally, 32 plus 8 is we're on the 40th day. 15 gets cut in half, 7.5 grams. So you can fill out this table. You can look at the graph, but you should be able to answer these questions based on both or one of the two. We know what the half-life is. It's 8 days. We used our graph. We started at 240. What's half of that? 120. We found where 120 was. That took 8 days to get there. Then what will the mass of the sample be after one half-life? One half-life is one group of 8 days. After 8 days goes by, it's now 120 grams. What will the mass of the sample be after 2 half-lives? Well, that means that value gets cut in half again. Now we go from 120 down to 60. One half-life, another half-life. So 60 grams. And how long will it be until their supply reaches 7.5 grams? That is over here. You can answer this and say 5 half-lives, or you can give the elapsed time and say that would be 40 days. Okay, so either one will help answer that question. That's a pretty basic question. Starting with the amount that you have at time 0, you have to figure out the half-life there. So just when you know what you start with, cut it in half, and then look at your graph and figure out how long that took.